In the silence of the cosmos, there are no footsteps, no winds, no whispers, only the soft hum of gravity weaving its invisible threads through the endless night. Stars burn like watchtowers scattered across an infinite ocean, their light crossing millennia to reach us, their voices speaking from a past already gone. Yet within this vast stillness drifts something darker, quieter, and infinitely more patient. A black hole, a remnant of a once-living star, glides through the galaxy with neither sound nor light to betray its presence. It does not shine. It does not announce itself. It bends reality by existing, dragging the fabric of space-time into a silent whirlpool. It does not chase. It does not hurry. It does not rage. It moves with the patience of eternity, a wanderer older than memory, obeying only the hidden laws of gravity. Somewhere, far beyond the reach of the naked eye, one such traveler drifts on a trajectory that leans, however faintly, toward our fragile home. It is not racing, not hunting, only moving with the inevitability of mathematics, with the certainty that in time, even the slowest journeys reach their destinations. And so the question rises, heavy and unshakable. What happens when an object so immense it swallows light, so heavy it bends the meaning of reality itself, begins to move, even slowly, toward the Earth? The story of the black hole begins long before anyone had the words to name it. For most of human history, the night sky was a canvas of certainty, a quiet stage where stars shimmered like eternal fires. To the ancient mind, the heavens were a place of permanence, untouched by decay. Stars were immortal, and the dark between them was nothing more than emptiness. Yet hidden in that darkness were objects so strange that even the brightest imagination could not have conceived them. They were not stars, not planets, not even shadows. They were the ruins of suns, so heavy, so compressed, that space and time themselves bent inward, collapsing into silence. The first hints did not come from myth, but from equations. In 1916, while the world was breaking itself apart in war, a German physicist named Karl Schwarzschild sat beneath the shadow of illness and worked through Einstein's brand new general theory of relativity. Einstein had revealed that gravity was not an invisible force, but the warping of space-time itself. Schwarzschild took that insight further. He found a solution that described what would happen if a mass collapsed into a point so dense that its gravity curved space into a perfect sphere, a trap from which not even light could escape. It was mathematics, nothing more. To many at the time, it seemed less like physics and more like a riddle, a ghost hidden inside numbers. For decades, scientists dismissed it as an absurdity, a theoretical corner of the equations that nature would never allow. Even Einstein himself doubted such objects could exist. But the universe is not beholden to human disbelief. By the middle of the 20th century, telescopes began to reveal stars that behaved in ways no ordinary star should. Some of them orbited invisible companions, circling like tethered dancers around a partner that gave off no light. And yet, that unseen partner pulled with the weight of many suns. The first great shock came in the 1960s, when astronomers detected powerful bursts of X-rays from the constellation Cygnus. At the heart of that region was a strange system, a visible blue star, massive and luminous, and beside it, something unseen, pulling matter away, devouring it in streams that lit up the void with violent radiation. That object was named Cygnus X1, and it was the first strong evidence that black holes were not just mathematical fantasies, but real, living actors in the galaxy. The very concept unsettled even the greatest physicists. Stephen Hawking bet against their reality, only to later concede when the evidence grew overwhelming. What began as one detection turned into a pattern. More X-ray binaries were found, each harboring an invisible companion of crushing mass. By the close of the century, the idea of black holes had shifted from speculative oddity to central truth. They were not rare, they were not exotic, they were everywhere. Born from the deaths of massive stars, they dotted the galaxy in the millions, silent remnants scattered like ashes across the cosmic sea. But as instruments grew sharper and surveys mapped the motions of stars with ever finer precision, a new and disquieting picture emerged. Not all black holes sat tethered in binary systems. Some drifted alone, without a companion star to betray their presence, without an accretion disk to announce their hunger. These were rogue black holes, wanderers set loose by the violence of supernovae or the recoil of cosmic collisions. They gave off no light, no signature, only the faint gravitational fingerprints on the stars around them. It was not until the Hubble Space Telescope and later the Gaia mission began charting the galaxy with unprecedented detail that scientists glimpsed just how many of these silent travelers might exist. Gaia mapped more than 1 billion stars, watching their positions shift with the delicacy of a watchmaker. Hidden in those tiny wobbles were clues to unseen masses tugging at them. Some were faint stars, but some were heavier, darker, invisible. Calculations suggested that the Milky Way might harbor more than 100 million black holes, most of them drifting alone. And it was here, in the quiet arithmetic of stellar motions, that the unsettling realization took shape. If so many black holes existed unseen, then their paths must weave through the same galaxy that shelters Earth. Some were far, millions of light years away. But some were near, within thousands of light years, passing silently through the dark between stars. A few were measured, others were inferred. All of them shared one defining trait. They were not fixed, they were moving. Even a slow drift, 10 kilometers per second, becomes immense when measured across cosmic time. Stars shift, orbits cross, trajectories bend. And when the universe is patient enough, even the faintest motion can become a destiny. Somewhere out there, beyond the range of human eyes, a black hole is not merely existing, it is traveling, and its path leans, however faintly, toward us. The discovery of black holes was only the beginning. To understand their presence in our galaxy was to confront something more profound. They were not exotic visitors at the edges of the cosmos, but neighbors, woven into the same stellar neighborhoods that cradle our sun. Once, they were thought to be rare. Now, they appeared abundant, scattered like embers of dead stars across the spiral arms of the Milky Way. And with every new discovery came a deeper unease. For if there were millions of them, what kept them distant from us? The truth is that the Milky Way is not a still canvas, but a restless current. Stars orbit the galactic center like water in a vast whirlpool, each pulled by the invisible weight of dark matter and the central black hole, Sagittarius A. Over millions of years, their paths shift, their orbits bend, and sometimes they are nudged into new trajectories. Black holes, unanchored and unseen, follow the same currents. Some are kicked away at tremendous speeds by the death throes of supernovae, cast adrift like stones flung into a pond. Others are ejected from star clusters after violent encounters. their paths altered forever. Each becomes a solitary traveler, gliding without light, without sound, through the spaces between suns. In 2022, astronomers confirmed the first detection of a truly free-floating black hole. It was found not by its light, but by its shadowing gravity. As it passed in front of a distant star, its mass bent the star's light into a faint lens, magnifying it just enough to reveal the presence of an invisible object about 7 times the mass of our Sun. The event lasted months, and the conclusion was unavoidable. Here, in the dark between stars, a lone black hole drifted unseen until chance aligned it with our gaze. Such a detection was a triumph of patience, but it also raised a haunting implication. If one could be found by accident in the infinitesimal alignment of star and observer, how many more wander just beyond reach? The mathematics pointed to an ocean of them, hidden in plain sight, moving silently through the same galaxy that holds our fragile world. Some are remnants of ancient stars, born long before Earth's first life stirred in its seas. Others are younger, recent deaths of massive suns whose collapse was hidden from our view. All of them glide under the same gravitational laws, obeying the same currents, bound by no allegiance except the pull of the galaxy itself. To imagine them is to picture shadows swimming in the dark. They give no warning. They emit no light. Only when they brush against the thin gas of interstellar space do they sometimes leave a trace, faint ripples of radiation stirred by their invisible hunger. Otherwise, they are silence incarnate, black against black, advancing on paths traced by the blind hands of gravity. It is within this quiet reality that a question sharpens. If so many exist, if their paths are countless and unlit, then what are the chances that one of them, even slowly, moves toward us? The answer is unsettling. Over spans of millions of years, the galaxy becomes a restless tide. Distances collapse under the patience of time. What seems impossible on the scale of human lives becomes inevitable on the scale of cosmic history. A black hole does not need to rush. It does not need to chase. It moves with the inevitability of orbits and the certainty of mathematics. And somewhere among the hundreds of millions, one such wanderer may already be on a path that points faintly, silently toward the Earth. This realization is not born from fantasy, but from observation. Scientists do not imagine black holes moving. They have seen the stars themselves displaced by invisible companions, their orbits betraying the silent pull of mass that should not be there. They have calculated how many stellar deaths have occurred since the birth of the Milky Way, and from that, how many remnants must remain. The numbers tell the story. The galaxy is alive with these hidden travelers, their movements untracked, their destinations unknown. And so, beneath the calm glow of our sun, beneath the comfort of familiar skies, there lingers a truth that feels almost mythic. Somewhere in the dark, without light, without sound, a black hole moves. It is not racing, not hunting. It does not know we exist. It drifts on with the patience of eternity. But patience, in the language of the cosmos, is only another word for inevitability. The realization that black holes were real was not simply a discovery. It was a rupture in the way humanity understood the universe. For centuries, gravity had been seen as a gentle force, the invisible thread that held planets to their stars and stars to their galaxies. It was Newton's great law, the steady clockwork of the heavens. Yet black holes revealed a side of gravity that was violent, absolute, and merciless. They showed that gravity was not only a guide, but also a predator, capable of collapsing a star into nothingness and bending the fabric of reality into a funnel from which no escape was possible. To the human mind, the very idea felt impossible, like a paradox hidden inside the laws of nature. The scientific world struggled to accept it. Even Einstein, whose equations first made them possible, recoiled at the thought that the universe could allow such monsters to exist. They seemed to break the rules. How could something have mass, yet no surface? How could it contain information, yet show nothing to the outside world but silence? To believe in black holes was to admit that the universe had edges not of space, but of understanding itself. When the evidence grew undeniable, the shock deepened. The X-ray signals from Cygnus X1 showed a companion heavier than the Sun, but invisible to every telescope. The gravitational waves detected a generation later told of black holes colliding, rippling spacetime like stones dropped into an endless pond. The laws of physics did not just allow them, they demanded them. And the more astronomers searched, the more they found. Black holes were not rare intrusions. They were common, as natural to the galaxy as stars themselves. What unsettled scientists most was not their existence, but their behavior. Black holes did not remain still. They could drift, wander, or be hurled across the galaxy at terrifying speeds. Some traveled hundreds of kilometers per second, fast enough to cross from one side of the Milky Way to the other. Others moved slowly, but inexorably, guided by the same galactic currents that carry the stars. They were invisible, unstoppable, and indifferent. A new category of danger, unlike anything known before. To imagine one passing near our solar system was to imagine disruption on a scale beyond measure. Even at a distance of light years, the pull of such an object could distort the fragile balance of planets and comets. It would not need to touch the Earth to bring catastrophe. A shift in the orbits, a disturbance in the Oort cloud, and the solar system could be thrown into chaos. The idea was almost unbearable, and yet it followed directly from the math. If black holes were so numerous, if they wandered freely, then somewhere, someday, one would pass close enough to remind us of our fragility. It was a scientific truth that carried the weight of fear. The universe was not a static stage, but a restless sea, and drifting through it were objects so dense they bent the rules of reality. The shock was not only that they existed, but that they moved, and that, in the patient language of cosmic time, even the slowest traveler could one day arrive. The deeper astronomers looked, the more unsettling the revelations became. For centuries, human beings had lived with the comfort of distance. Stars might flare and collapse, but they were far away, separated from us by oceans of space. What danger could they possibly bring to our small world? Yet black holes shattered that sense of safety. Unlike stars, they did not burn brightly, warning us of their presence. They moved unseen, carried by the hidden rivers of the galaxy. Their danger was not only their hunger, but their silence. In the late 20th century, scientists began to realize just how dynamic these objects could be. When a massive star collapses, the explosion is rarely symmetrical. The blast can send the newborn black hole flying at hundreds of kilometers per second, a velocity greater than the escape speed of most star systems. Such a kick would fling it outward, turning it into a rogue traveler, condemned to drift across the Milky Way. Astronomers calculated that over the billions of years of our galaxy's history, countless such kicks must have occurred. Each one released another dark wanderer into the void. Then came the measurements. Gravitational microlensing surveys revealed invisible masses bending the light of background stars. The Gaia spacecraft mapped subtle deviations in stellar paths, hinting at massive but unseen neighbors. Every clue told the same story. The galaxy was not an orderly clockwork of shining points, but a labyrinth threaded with silent predators. The shock was not in one discovery, but in the scale of the pattern. Where once black holes were thought to be rare, now they appeared to number in the hundreds of millions. They were not far away in some remote corner of space, but here, among the spiral arms that cradle our own sun. The psychological weight of this knowledge was immense. Humanity had faced cosmic threats before: comets, asteroids, and solar storms. But those were visible, tangible, and within the reach of human calculation. A black hole was different. It gave no warning, no light, no signal until its gravity touched something close. And once it did, there was no shield, no defense, no second chance. The very fabric of space-time itself would be bent, and the solar system's delicate balance could unravel. Scientists spoke of probabilities, of timescales spanning millions of years, of distances that softened the immediate threat. But beneath the careful language of research lay an unspoken truth. The universe was not designed to keep us safe. It was indifferent, its laws working without pause, without mercy. A black hole need not be fast to be dangerous. In the slow arithmetic of galactic orbits, even a wanderer drifting at tens of kilometers per second would, in the course of eons, cross light years and approach new regions of space. What felt infinite and empty was, in truth, filled with hidden motion. And so the shock lingered, heavier than the data itself. To live in a galaxy alive with black holes was to live with the knowledge that the ground beneath our cosmic feet was not steady. Our solar system, for all its stability, was adrift in a wider storm, and somewhere within that storm, unseen and patient, a black hole was moving. Not toward us with intent, not as a hunter, but simply as a fact of nature. Its approach was not certain, not imminent, but possible. And in the language of the cosmos, possibility stretches into inevitability when given enough time. This was the true terror of the discovery. Not that black holes exist, but that they travel. They are not chained to the edges of the universe, but wanderers, scattered through the very galaxy we call home. Their silence is not safety. It is only the quiet before their paths and ours may one day cross. The discovery of black holes shook astronomy, but it was only the beginning. What followed was the slow, meticulous attempt to measure them, to place numbers on objects that swallowed numbers whole. How do you study something that gives off no light, that hides itself completely from view? The answer came not from seeing, but from tracing their shadows in the world around them. Astronomers turned first to the stars themselves. With the arrival of the Gaia spacecraft, the galaxy became a living map. Gaia did not simply photograph the heavens. It measured the positions and motions of more than 1 billion stars with exquisite precision. Each star became a point in a vast celestial dance, its movement recorded year after year. And in those motions, tiny wobbles appeared, betrayals of hidden companions. Some of those companions were other stars, too faint to see. But some wobbles told of something heavier, denser, yet invisible. the unmistakable fingerprint of a black hole drifting nearby. The method was delicate, like listening for footsteps in a crowded hall. But again and again, the patterns pointed to unseen masses, and in 2022, one of them revealed itself with extraordinary clarity. As a black hole passed in front of a distant star, its gravity bent the light, acting as a cosmic lens. The background star brightened, distorted, and then returned to normal as the black hole drifted away. This fleeting event, lasting months, was the first direct detection of a solitary black hole, confirmed not by speculation, but by data. Its mass was measured at 7 times that of the Sun, and yet it was invisible, a dark traveler passing unnoticed through the galaxy until the accident of geometry brought it to light. This discovery raised both triumph and unease. Triumph, because it proved that humanity's instruments were now sensitive enough to find the most silent of cosmic predators. Unease, because if one could be seen by chance, how many others remained unseen? For every black hole that revealed itself through gravitational lensing, there must be thousands that did not happen to align. The sky, so familiar and mapped, was filled with invisible wanderers that no telescope could trace. Beyond Gaia, other instruments sharpened the picture. The Very Long Baseline Array links radio telescopes across continents, creating a single dish the size of Earth. With it, astronomers could detect the faintest jets of matter spiraling around hidden objects, sometimes betraying a black hole that had otherwise remained dark. The Event Horizon Telescope took it further, imaging the very edge of black holes in distant galaxies, proving the mathematics of general relativity against the most extreme conditions in nature. But the most haunting data came not from light at all, but from ripples in space-time itself. With the Laser Interferometer Gravitational Wave Observatory, physicists captured the aftershocks of black holes colliding. An entire sun's worth of mass was converted into waves that shook the fabric of the universe. These were not distant myths. They were real events, unfolding billions of light years away, their echoes reaching Earth with the precision of a cosmic clock. Each detection confirmed that black holes were not passive relics, but active forces in the galaxy, moving, colliding, and reshaping the very geometry of existence. The deeper scientists looked, the more patterns emerged. They calculated the distribution of stellar remnants, tracing how many massive stars had lived and died in the Milky Way. From those deaths, they estimated the number of black holes, 100 million or more, scattered across the spiral arms, some clustered in remnants of star-forming regions. Others drifted alone, set adrift by the violence of their birth. The sheer number painted a sobering picture. Our galaxy was not a quiet sea, but a vast archipelago of invisible islands, each carrying the weight of collapsed suns. And within this swarm, one truth lingered: they were not fixed in place. Each one followed a path shaped by gravity, and across the span of millions of years, those paths would weave, shift, and cross. To search for them was to listen for thunder in the silence of space, to hunt for shadows that bent the stars themselves. It was a search that revealed not only the presence of black holes, but the terrifying possibility that one of them, moving slowly but inevitably, was drifting toward the fragile orbit of Earth. The search for black holes deepened as technology advanced. Each generation of instruments peeled back another layer of the invisible, but each revelation also sharpened the unease. Astronomers realized that if they could track the motions of stars with enough precision, they could map not only the stars themselves, but also the unseen weights tugging at them. A star that swerved too sharply or drifted with a wobble too subtle for the naked eye betrayed the presence of an unseen companion. Some of those companions were faint brown dwarfs. Others were ghosts heavier than any star could be, black holes moving silently through the night. Gaia's maps revealed that even in regions once thought empty, stars behaved as if disturbed by something hidden. Calculations suggested that every few hundred light-years, a rogue black hole might be wandering. That number, scaled to the size of the galaxy, hinted at a population so vast it seemed almost impossible. Tens of millions of invisible wanderers, most never seen, most never suspected, gliding along trajectories that stretched across galactic arms. What unsettled scientists most was not their abundance, but their secrecy. They did not announce themselves with heat or light. Unless they consumed nearby matter or happened to pass in front of a background star, they were as invisible as silence itself. Other methods began to fill the gaps. Sensitive X-ray surveys looked for faint emissions from gas heated as it spiraled into hidden wells of gravity. Radio telescopes hunted for distortions in the jets of distant quasars, where the gravitational influence of foreground black holes bent the signal. Even neutrino detectors, instruments buried beneath ice and water, were considered as possible tools to sense the rare particles unleashed by matter collapsing into the abyss. Each tool was a new ear pressed to the silence, straining to hear what refused to speak. The more evidence was gathered, the more the picture sharpened. Black holes were not exotic rarities, but part of the fabric of our galaxy. Some, like Sagittarius A star at the galactic center, were giants anchoring the orbits of billions of stars. Others were tiny in comparison, only a few times the mass of the sun, scattered like seeds of death across the spiral arms. Together, they formed an invisible structure, a second galaxy hidden within the first, one made not of light, but of gravity. And among these countless wanderers, the probability grew clear. If millions of them existed, then some must pass near our solar system, across the sweep of cosmic time. Even if the odds for any given century were small, stretched across millions of years, the numbers bent toward inevitability. A black hole did not need to strike the Earth to bring disaster. A distant pass through the Oort cloud could disturb trillions of icy bodies, sending storms of comets plunging toward the inner planets. A closer approach could shift the orbits of the outer worlds, reshaping the solar system into chaos. The deeper the investigation went, the more fragile Earth seemed. Civilization was built under the illusion of stability, under the quiet assumption that the heavens above were fixed and safe. But the instruments told another story. They revealed that the galaxy was alive with motion, with gravity's endless dance, and that somewhere in that restless tide, a black hole was moving in our direction. It would not arrive tomorrow, or even in the span of human history, but in the language of the cosmos, measured in millions and billions of years. Such an encounter was not only possible, it was inevitable. The investigation did not end in reassurance. It ended in awareness. For every star mapped, for every hidden mass detected, there remained countless others unseen. And each discovery was a reminder. The universe is vast, its dangers silent, its predators patient. Somewhere in the dark, another black hole drifts forward, unseen, its path as certain as the pull of gravity itself. The realization that black holes were common was unsettling enough. But the deeper scientists traced their paths, the more frightening the picture became. A black hole is not a passive monument, frozen in the place where it was born. It is a traveler, set in motion by violence. When a massive star collapses unevenly, the explosion imparts a kick, sending the newborn black hole flying. When two black holes merge, their collision can unleash a recoil strong enough to fling the remnant away at thousands of kilometers per second. Even the quiet tug of nearby stars can nudge their orbits over millions of years. And so these dark remnants are not fixed. They wander, carried on currents of gravity that ripple through the galaxy. The numbers themselves carry a kind of terror. A black hole moving at 100 kilometers per second could cross the distance between stars in just a few million years. That is slow compared to human lives. But in the language of the galaxy, it is motion enough to redraw maps, enough to change futures. Some move far faster. A handful have been measured tearing across the Milky Way at speeds greater than escape velocity, ejected into intergalactic space by cosmic collisions. But most drift more slowly, tens of kilometers per second, steady and unstoppable. These are the wanderers that remain within the spiral arms, crossing the same regions where stars like the Sun reside. What makes them terrifying is not only their speed, but their invisibility. They do not shine, they do not glow. A rogue black hole could be only a few dozen light years away, and unless it happened to betray itself through gravitational lensing, we would never know. The absence of evidence is not safety, it is only blindness. And as Gaia's data grew more precise, it became clear that stars within our own stellar neighborhood showed subtle deviations, unexplained motions that hinted at the presence of massive, unseen companions. Perhaps they were faint stars, perhaps they were something darker. The possibility lingered, heavy and unshakable. Even distance offers less comfort than it once did. A black hole need not approach within the orbit of Earth to bring chaos. And a distance of just a few light years, its gravity could disturb the Oort cloud, a shell of icy bodies that circles the solar system like a frozen halo. A passing black hole could send those bodies cascading inward, triggering waves of comets that bombard the inner planets. Closer still, and the balance of the outer planets themselves could unravel, their orbits twisted, their motions destabilized. At the extreme, if one were to drift directly into the solar system, its gravity would overwhelm everything. Planets could be flung into space, Earth stripped from its orbit, or drawn slowly toward a horizon of no return. The terror lies not in imagination, but in inevitability. The Milky Way is a restless system. Stars shift, spiral arms drift, and over the vast cycles of galactic time, paths intersect. Astronomers know of rogue stars moving toward our neighborhood. If stars can wander into our skies, why not black holes? In the calculus of millions of years, probability bends toward certainty. Somewhere, hidden in the dark, a black hole is moving. And with each passing moment, the distance it must travel grows shorter. As the investigation deepened, the mystery became heavier, almost unbearable in its implications. It was no longer a question of whether black holes moved, but how many, how fast, and along which invisible paths they drifted. Each discovery sharpened the same conclusion. The galaxy is alive with motion, and black holes are among its most restless travelers. They are born in violence and carry that violence with them. Some astronomers turn to models, running vast simulations of the Milky Way. They filled the virtual galaxy with stars and remnants, watching them move over billions of years. The results were sobering. Black holes did not remain scattered in random isolation. They drifted along streams, aligned with the arms of the galaxy, carried like leaves in a tide. In those models, some passed disturbingly close to stars like the Sun. The chances of a direct collision were small, but the chances of a near miss were not. And in cosmic terms, a near miss is enough to unravel everything. One scenario haunted the discussions. What if a rogue black hole approached within a few light years? The Oort cloud, a vast, delicate reservoir of icy worlds, would not survive untouched. A single gravitational nudge could disturb millions of objects, sending a slow, relentless storm of comets toward the inner planets. Earth, which has already borne the scars of impacts, would face bombardment on a scale unimaginable. Life itself might be reset, civilizations reduced to whispers in stone. But the thought does not end there. Astronomers considered closer passes, scenarios where a black hole came within a fraction of a light year, tugging at the planets themselves. A gas giant could be displaced, its orbit tilted. The delicate rhythm of resonances that holds the solar system together could collapse. Earth might find itself in a new orbit, its climate transformed beyond survival. Or worse, the planet might be flung out entirely. Cast into the darkness of interstellar space, an exile with no sun to warm its oceans. And at the most extreme, though rare, is the unthinkable. A black hole on a direct course, not just near, but into the solar system itself. The mathematics of such an encounter are merciless. The orbits of the planets would dissolve. Some might spiral inward, others would be hurled outward. Earth could be consumed, its matter stretched into thin streams, its history erased in a silence so complete that even light would fail to carry the memory away. The scientific language for these scenarios is calm, precise, filled with probabilities and distances. But behind the numbers lingers an emotional truth. We live in a galaxy where such possibilities are real. They are not fantasies, they are not myths, they are consequences of the laws of gravity, playing out across spans of time too long for human lives, but not too long for the universe itself. The danger does not lie in speed, it lies in patience. A black hole does not rush, it does not hunt, but given enough time, even the slowest of them will arrive. This deepening of the mystery shifts the perspective. Black holes are no longer only distant objects at the edges of imagination. They are part of the living structure of the Milky Way, woven into its arms, its clusters, its streams. They are not separate from us. They are with us, in the same galaxy, moving under the same laws and bound to the same restless currents. The silence of the night sky, once a comfort, becomes a reminder. It is filled not with emptiness, but with wanderers whose presence is hidden, whose approach is inevitable. In the quiet arithmetic of gravity, there are reasons a black hole drifts, and reasons its path might lean toward a star like the Sun. It begins with the physics of birth. When a massive star collapses, the explosion is rarely symmetrical. Jets carve through one hemisphere more than the other. Shockwaves break unevenly, and the newborn remnant receives a push. Astronomers call it a natal kick. Neutron stars often depart their birthplaces at hundreds of kilometers per second. Black holes, heavier and harder to jolt, still inherit motion from the imperfect violence that made them. Some remain bound to their stellar neighborhoods. Others, with a single shove, become wanderers, cast into the wider tides of the galaxy. Another path into motion comes much later, when two black holes meet. Their in-spiral radiates energy away as gravitational waves, rippling space-time with an imbalance that can recoil the merged remnant like a cannon shot. In computer models, such recoils can reach thousands of kilometers per second, for the right spin alignment. Even at far gentler speeds, the effect is decisive. A remnant can be dislodged from a cluster, escorted out of a dwarf galaxy, or set adrift inside a spiral arm. In the slow clock of the Milky Way, each of these events is common enough that, over billions of years, the galaxy accumulates a population of dark travelers, some fast, some slow, all governed by the same law. The path taken yesterday shapes the encounter that comes tomorrow. Gravity then does the quiet rest. Environments busy with stars, open clusters, associations, streams left by shredded dwarf galaxies, exchange momentum through countless weak encounters. A pass that barely registers still tugs a trajectory by a fraction of a degree, and the accumulation of such fractions changes destinations. Over 1 million years, a black hole traveling 30 kilometers per second crosses roughly a parsec. Over 3 million, it crosses 10. Over 30 million, 100. The speed is unhurried. The distance traveled is enormous. On these scales, what appears static from the ground is a long migration, a reshuffling that brings strangers into the same neighborhood. Theories trace not only the motions, but the kinds of black holes that might wander. Most are stellar remnants, a few to a few tens of solar masses, born in the depths of short-lived heavy stars. A rarer class may be heavier, intermediate mass black holes, grown inside star clusters or carved from the remnants of many mergers. Their very existence remains debated, yet hints appear in the dynamics of some clusters and the odd flare of a star torn apart where no supermassive anchor lies. If such an intermediate mass object drifts through a spiral arm, the reach of its gravity extends farther. The radius at which it can disturb a planetary system grown large by mass alone. In the ledger of risk, mass is a multiplier. There are older, bolder ideas as well. Some cosmological models allow for primordial black holes, formed not from stars, but from density spikes in the earliest moments after the Big Bang. Most mass ranges for such objects have been constrained by surveys, yet gaps in the limits persist. In those gaps sit speculations. Could a small fraction of dark matter be ancient black holes? Could an unseen object in the outer solar system, an explanation sought for oddities in the orbits of distant Kuiper Belt bodies, be a compact remnant rather than a hidden planet? The proposals remain contested, their evidence thin, and their alternatives plausible. But they are not idle fantasies. They inhabit the current edge of what the data permits, and they map the contours of what the galaxy might still hide. If a black hole is drifting, its influence depends on distance, velocity, and mass. The equations are simple in form, but merciless in consequence. The Schwarzschild radius, the horizon beyond which light cannot escape, scales with mass at roughly 3 kilometers per solar mass. A 7 solar mass black hole would have a horizon about 20 kilometers across, a smallness that misleads. Its true reach is set not by the horizon, but by the range over which its gravity competes. Far from the object, the force is gentle. Close in, it steepens like a cliff. A passing trajectory is sculpted not only by the black hole's mass, but by the speed of the encounter. Slower passes allow gravity more time to act, bending paths more strongly, capturing loose debris that would otherwise escape. In the outer dark, where comets drift in fragile equilibrium, such a time is decisive. The solar system's most vulnerable skin is the Oort cloud, a distant swarm of ice and dust extending, by some estimates, to 100,000 astronomical units. It is held weakly to the Sun, more by the habit of orbits than by tight bonds. Galactic tides and passing stars already stir it from time to time. A black hole, even at several light-years, would deepen the stir into a wide, slow storm. Theories model a census of perturbations. A pass within a light-year could increase the inward flux of comets for hundreds of thousands of years, not as a single catastrophe, but as an era of heightened risk, an extended season of falling glass. Closer approaches compound the effect, and at fractions of a light-year, the geometry turns from a distant nudge to a reweaving of orbits. For planets, thresholds are nearer. The Hill sphere of the Sun, the region where its gravity dominates over the galaxies, extends well beyond Neptune. A black hole entering this domain would rewrite the problem. Theories outline families of outcomes: resonances disrupted, long-period orbits rephased, gas giants exchanged, tiny changes in momentum that cascade over ages into altered architectures. Earth's safety in such models hangs in the balance. At several hundred astronomical units, the effects may be negligible. At tens, they magnify. At single-digit units, the solar system becomes an experiment with unpredictable results. The black hole never needs to touch the world to transform it. Against these maps of danger, there is a balancing sobriety. The probabilities in any given human era are small. The sun moves within a local bubble of hot, thin gas. The nearest known black holes are far, and the sky offers no sign of an approaching heavy shadow. Dark energy, which accelerates the expansion of the universe on the largest scales, has no leverage here. The solar system and the stars around it are gravitationally bound, their motions set by near-field gravity, not by the pull of the cosmic expansion. In the near term, the galaxy is at a closed stage. In the long term, it is a play with many acts, and the casting call includes objects that do not speak until they stand in the wings. Both truths must be held at once. The present is likely safe. The future, stretched across millions of years, admits encounters that probability alone deems likely. Speculation, carefully separated from what is known, sketches possibilities rather than promises. One sketch follows a modest black hole through the local arm, its course nudged by a past cluster encounter, its speed a quiet 30 kilometers per second. It crosses 10 parsecs in 3 million years, nearer than the great majority of stars ever come, yet still comfortably distant. The Oort cloud trembles. The inner planets never notice. Another sketch posits a heavier traveler, an intermediate mass object on a rare path inside a light year. The cometary halo responds like a bell, ringing for an age. A third sketch, the rarest, allows a pass well within the realm of planets. Orbits shift. A gas giant acquires a subtle eccentricity. A century later, nothing looks amiss. A million years later, the system is another place. In each sketch, the universe keeps no ledger of mercy or malice. It keeps only the equation. There is an ethical gravity to these theories. They are not predictions shouted into the near future, but reflections on the scale at which the galaxy moves. They ask a civilization to weigh its sense of permanence against the pace of the cosmos. They suggest that vigilance is not panic, and that humility is not surrender. Knowing that a black hole can drift toward the Earth means understanding that safety is never an absolute condition in space. It is a temporary arrangement negotiated by distance and time. The speculation does not diminish the beauty of the sky. It deepens it by revealing how much of its order is won against the quiet pressure of the unseen. In the end, the theories return to the same center. The black hole that moves slowly is not a threat because it chooses, but because gravity has no choice. Its path is the sum of births and encounters, kicks and recoils, tides and chance. The Earth, too, rides a path set by a past it did not choose, orbiting a star that orbits a center it will never see. Between these courses lies the meaning of risk in the galaxy. Two stories written in the same script of curvature. Moving through one another's possibilities, patient as stone, inevitable as math. If the presence of rogue black holes is unsettling, the explanations surrounding them are even more so. Each theory does more than explain, it stretches the imagination, pulling human thought into places where the rules of ordinary life no longer apply. Some scientists look to the past, to the death of stars, to understand why these wanderers exist. Others look forward, into speculation, wondering what their approach could mean for the fragile architecture of our solar system. One line of speculation turns toward the structure of the Milky Way itself. The galaxy is not uniform. It is a system in motion, its spiral arms shifting like the slow waves of an ocean. Within these arms lie streams of stars, remnants of smaller galaxies torn apart by gravity, their debris now woven into the wider disk. Black holes travel within these streams, just as stars do, invisible passengers caught in the tidal remnants of ancient collisions. If Earth's orbit around the galactic center carries us through such a stream, we do not pass only through stars and gas, but through unseen remnants as well. In this view, the threat is not isolated, not rare, but woven into the very fabric of our galactic journey. Others look deeper, into the question of origins. Could some black holes be older than the stars themselves? The idea of primordial black holes remains one of the most audacious hypotheses in modern cosmology. If, in the early universe, density fluctuations were extreme enough, pockets of matter could have collapsed directly into black holes only fractions of a second after the Big Bang. These objects would not be the ashes of stars, but fossils of creation itself. Most mass ranges for such objects are ruled out, constrained by careful surveys, but gaps remain. Within those gaps lies possibility. Perhaps some fraction of the invisible mass we call dark matter is nothing more than an ocean of ancient black holes, drifting silently through the cosmos since time began. This idea stirs a more local speculation. In the outer reaches of the solar system, far beyond Neptune, astronomers have noted peculiarities in the orbits of distant icy bodies. Some seem to cluster, their paths oddly aligned, as if tugged by a hidden mass. The simplest explanation is a distant, undiscovered planet, often called Planet 9. But some scientists have asked a darker question. Could the hidden shepherd be a black hole, perhaps a remnant of a star long gone, or even a primordial survivor from the dawn of time? If so, it would be a worldless traveler, orbiting our sun unseen, exerting its influence without light, a neighbor we could not recognize except by its pull. The evidence remains inconclusive, and the hypothesis contested. Yet it illustrates the weight of possibility that black holes cast into every unexplained pattern of motion. Theories also consider not just what these objects are, but what they might do when they pass close. Some researchers run simulations of near encounters, asking how planetary systems respond when a black hole drifts through their neighborhoods. The results vary by distance and mass, but the theme is constant: disruption. At several light years, the effect is subtle, a reshaping of cometary orbits. At fractions of a light year, the results become severe, with planets shifted, resonances broken, and systems destabilized. At closer distances, the simulations unravel into chaos, with worlds flung outward into exile or drawn inward toward annihilation. Each scenario is not a prediction, but a sketch of possibility, a map of what gravity makes unavoidable when distances collapse. The speculation grows darker still when physicists consider the possibility of false vacuums and cosmic phase transitions. If the universe's vacuum state is not absolute but metastable, then a disturbance could, in principle, trigger a collapse into a lower energy state, rewriting the laws of physics themselves. A drifting black hole, with its extremes of density, becomes part of such discussions, not as a trigger in any immediate sense, but in an immediate sense, but as a reminder that black holes are natural laboratories of energy and curvature, testing the universe at its breaking points. These ideas remain speculative, theoretical edges not yet grounded in observation, but they highlight how black holes force humanity to confront possibilities larger than stars, larger than galaxies, possibilities written into the structure of space-time itself. And in every speculation lies the same haunting refrain: inevitability. Theories differ in detail, in probability, in distance and scale. Some point to local risks, others to cosmic truths. Some describe dangers, others hint at opportunities to test physics at its limits. But all agree that black holes cannot be avoided. They are the consequence of stars, the conclusion of collapse, the inevitability of mass itself. As long as stars live and die, black holes will form. As long as the galaxy moves, they will drift. And as long as time stretches forward, they will cross paths with other systems, ours among them. The speculation does not erase the wonder. To imagine a primordial black hole orbiting our sun is not only to imagine danger, but to glimpse history older than galaxies. To consider a rogue remnant passing near the solar system is to recognize how fragile and precious the balance of our world is. Each theory, however unsettling, is also a reminder. We are witnesses in a universe that is not empty, but alive, restless, filled with unseen travelers whose silence carries both mystery and inevitability. To face a danger that cannot be seen, humanity has turned its ingenuity toward building eyes that do not rely on light. For centuries, astronomy was bound to the visible spectrum, to glass and mirrors that gathered starlight. But black holes reveal themselves not by shining, but by bending, by pulling, by disturbing the space and stars around them. And so the search for them has become a search for disturbances, for echoes, for the faintest whispers of their presence. One of the greatest advances came with Gaia, a spacecraft launched by the European Space Agency. Unlike telescopes designed for images, Gaia's mission was to measure. With patient precision, it tracked the positions and motions of more than 1 billion stars, recording their dance across the sky with accuracy down to micro-arcseconds. Such detail is like watching a coin shift on the surface of the moon. And in those shifts, scientists began to notice patterns. Some stars wobbled as though tethered to invisible companions. Others veered subtly, their paths bent by massive objects no telescope could see. Gaia was not looking for black holes directly, yet its data became a map of gravitational footprints left behind by the unseen. Alongside Gaia's star maps, surveys of gravitational microlensing added another window. When a black hole passes in front of a distant star, its gravity bends the light, magnifying it for weeks or months. This phenomenon, predicted by Einstein a century ago, is rare. But in a galaxy of hundreds of billions of stars, rare is still frequent. In 2022, such a lens revealed the presence of a lone black hole, 7 times the mass of the Sun, the first of its kind, confirmed by direct observation of its effect on background starlight. This event was a proof of concept. Black holes that wander silently through the galaxy can, by accident of geometry, betray themselves through light they do not emit but bend. Other instruments push the search further. The Vera C. Rubin Observatory, soon to begin its deep sky survey, will scan the heavens night after night, compiling an archive of changes across time. It will not only catalog stars and galaxies, but catch transients, brief events when a black hole's presence distorts or devours matter. With such a record, astronomers hope to identify the rare signatures of black holes passing across the line of sight. Each detection, another piece in the puzzle of their hidden population. Sign. Yet not all tools rely on light at all. In 2015, humanity detected something new. Gravitational waves, ripples in space-time created by the merger of black holes. The Laser Interferometer Gravitational Wave Observatory, LIGO, and its counterparts in Europe and Japan opened a new era. Each chirp of detection, each faint shudder recorded by laser arms kilometers long, was the voice of black holes colliding billions of years away. These signals confirmed not only the existence of black holes, but their restless motion, their constant encounters, and their role as engines of change in the cosmos. In just a few years, dozens of such events have been cataloged, with more arriving each observing season. These tools work together like senses in a single body. Gaia provides the map of stellar motions. Microlensing reveals the chance alignments. Rubin will sweep the sky for flickers of change. LIGO listens for the tremors of collisions. The Very Long Baseline Array stitches radio dishes across continents to peer at jets near hidden companions. And the Event Horizon Telescope, linking observatories across the globe, has imaged the shadows of supermassive black holes in distant galaxies. Each tool brings its own kind of vision, and together they construct a portrait of the unseen. But in this growing arsenal lies an irony. The more instruments we build, the more black holes we find, the more their presence feels ubiquitous. They are not rare anomalies, but fundamental actors, shaping galaxies, sculpting orbits, drifting silently across the spiral arms. Every detection, every map, every ripple heard in the fabric of space-time deepens the same conclusion. Black holes are everywhere, and among them are wanderers. Some are far, but some are near, and some, inevitably, will pass close enough to matter. The search for rogue black holes is not just about understanding the galaxy. It is also about preparing for the possibility of encounters. To know where these objects are and where they are going is to reclaim a measure of foresight against forces that otherwise move unseen. And so the instruments grow not only in number, but in ambition. Each new mission is designed with sharper eyes, steadier patience, and a reach deeper into the fabric of the cosmos. Among these is the Rubin Observatory's Legacy Survey of Space and Time, a decade-long effort that will photograph the sky again and again, creating a time-lapse of the universe. By comparing millions of images, astronomers will detect not only supernovae and asteroid paths, but also the subtle signs of gravitational lensing caused by dark wanderers. A rogue black hole passing in front of a background star may reveal itself for just a season, a fleeting distortion hidden in a vast sea of data. With Rubin's sensitivity, those rare events will no longer vanish unnoticed. Other projects look outward through different windows. The Square Kilometre Array, rising from the deserts of Australia and South Africa, will be the largest radio telescope ever built. Its sheer sensitivity will allow it to trace faint radio emissions where black holes stir the thin gas of interstellar space, leaving whispers of energy as they pass. Meanwhile, space-based gravitational wave detectors such as LISA, scheduled for launch in the coming decade, will expand our ability to hear the universe, catching lower frequency waves from massive mergers that ground-based observatories cannot detect. Each detection adds another data point, another clue to the distribution and movement of these hidden masses. Closer to home, searches continue for signs of black holes that might lurk within our stellar neighborhood. Some astronomers use Gaia's data to comb the motions of stars within a few hundred light-years, looking for anomalies too heavy to be explained by faint companions. Others examine the strange alignments of distant Kuiper Belt objects, wondering if their shepherd is not a planet, but a black hole captured long ago. These ideas remain controversial, but they reflect a growing truth. The tools now exist to test them. The effort is global, a collaboration across continents and disciplines. Optical astronomers, radio engineers, particle physicists, and theorists share data, cross-checking signals that no single method could confirm alone. In the process, humanity is building not only a map of the visible sky, but of the invisible one as well, a cartography of gravity that includes both stars and the dark remnants that wander between them. And yet, even as the tools sharpen, the picture they reveal is sobering. Each new detection confirms that black holes are not distant abstractions, but present realities, scattered throughout the galaxy in staggering numbers. The better we look, the more common they appear. And though none have yet been found drifting directly toward Earth, the very scale of their population makes the possibility undeniable. The surveys are not just science, they are watchfulness, a way of keeping vigil in a universe where silence can carry the weight of threat. The work is far from finished. Every instrument is a beginning, not an end. Gaia will continue to refine its stellar map for years to come. Rubin will record a decade of changes. LISA will extend humanity's hearing into frequencies we have never touched before. Each will add to the chorus of data, bringing the unseen into focus. But even then, the search will not end. Black holes are not static. They move, they drift, they change neighborhoods. To know them is to accept that the search must be constant, renewed with every generation, passed from hand to hand across centuries. What these tools give us is not certainty, but awareness. They remind us that we live in a galaxy alive with motion, one in which invisible travelers move as surely as the stars we see. The instruments tell us not to fear blindly, but to listen carefully. They allow us to trade ignorance for vigilance, even if they cannot grant safety. And in their patient watchfulness lies a kind of hope that even in a universe filled with silent predators, we are not entirely blind. In the quiet of the night, when the stars seem eternal and the constellations appear fixed, it is easy to forget that the heavens are not a painting, but a river. Every star is moving, every system drifts, and somewhere within that current, invisible to the eye, yet heavy beyond comprehension, black holes slide silently, like shadows carved into the fabric of the universe. To live in such a cosmos is to live with a paradox, the comfort of beauty and the certainty of danger, woven together into the same sky. Human beings once looked upward with myths as their guides, imagining gods and spirits beyond the constellations. Today, we replace those stories with equations, telescopes, and maps of gravity. Yet the feeling is not so different. The knowledge that there are black holes wandering through the galaxy, silent, patient, unstoppable, echoes the same awe and fear that once filled ancient hearts. We are still small beneath the stars. We are still fragile beneath the weight of forces far beyond our scale. But there is something profoundly human in facing this truth. A black hole does not care about Earth, about life, about meaning. It does not know it drifts toward or away from us. It is only an outcome of physics, the remains of a star obeying gravity's law. Yet when we study it, when we chart its path, when we imagine its distant approach, we transform indifference into awareness. What was once only silence becomes a story, a reminder of how brief and precious our moment is on this planet of light and water. In this reflection lies no promise of safety. The universe does not guarantee survival, but neither does it deny wonder. To imagine a black hole drifting slowly toward Earth is to imagine time stretched beyond comprehension, to measure our lives against spans so vast that even mountains are fleeting. It is to see ourselves as we truly are, delicate. The mystery of a black hole drifting toward Earth is not just a question of physics. It is a mirror held up to our sense of time. For us, a century feels vast, a millennium unthinkable. But in the measure of the cosmos, these spans are no more than heartbeats. A black hole that moves slowly, at a pace of tens of kilometers per second, covers light years in the time it takes civilizations to rise and vanish. What feels distant and abstract to us is, in the mathematics of deep time, an inevitability waiting for its moment. And so the reflection sharpens. What does it mean to build, to hope, to love, in a universe where such forces move unseen? Perhaps it means recognizing that permanence is not the gift we imagined. The mountains will erode, the oceans will shift, the stars themselves will wander. Even the Earth may one day lose its orbit, undone not by malice, but by the silent weight of a traveler passing too close. Yet none of this erases the meaning of the present. Instead, it gives it weight. Every sunrise becomes rarer when measured against eternity. Every human story becomes more precious when framed by the silence of the void. Black holes remind us that we are not the center of the cosmos, but participants in it. They remind us that survival is never guaranteed, that the laws of physics hold dominion over even the most powerful star. But they also remind us of the gift of perception, the fragile miracle of awareness. To know that such mysteries exist, to measure them, to imagine their consequences, is to lift ourselves beyond the blindness of instinct. We are, for a brief time, the universe reflecting on itself, aware of both its beauty and its terror. And so the question lingers, not as fear, but as meditation. What happens when an object so heavy it bends reality itself begins to move toward us? The answer is not written yet, and perhaps it never will be within the span of our species. But in asking, we step into a larger frame of time. We become part of the story of the galaxy, fragile yet luminous, finite yet aware. In the end, that awareness is our answer, our defiance, and our peace beneath the restless tide of stars.